Okay, so let's look at the ransomware attack here. The first thing is the ransomware attack originated from a USB stick stuck into a user's laptop. And that was this WE8105 desk is the name of it. So we need to find the IP address of that desktop machine. So the simplest thing is just search for events that contain that name. Get rid of everything else. All right, if we do that, you should find 181,000 events with that name in it. So that's going to go for a while. I'm just going to turn on sampling to make it faster because I don't really care yet. I want to get some representative events. Okay, so I found 1,700 events because there's really 170,000 or so. Now I'm going to look at the source field. Here's source of various types. And what I want to do is find the stream sources with Active Directory logins. And Microsoft Active Directory logins work by LDAP. Here they are. Lightweight Directory Access Protocol is the protocol used to send login information on Microsoft domains. So I have only one event, so I better turn off the sampling to see them all. Now I got 74 events, and now I want to limit them to a certain day. And the day is 24 August 2016. So for that, you can use these time selectors, and I can go to date range. And it's going to be 24 August 2016. So between, 08, 24, 2016. Okay, and if you want just one day, you just put the same thing in both sides here because it's from 0 to 24. You'll see there, from 0 on this date to 24 on that date. That is stuff that happened on that day. Now, I had 74 events. When I do this, I now have 48 events. And if I look at the IP addresses here, the destination IP is 192.168.250.20, and the source IP is 192.168.250.100. So either it's kind of hard to know which way it's going, but the standard numbering convention for IP addresses applies. You typically number endpoint devices like laptops starting at 100 and going up, and the small numbers are typically servers. So this is the server address, and the desktop is that other number ending in 100. There. And also makes sense that it would be the source of these LDAP events because the login originates at the client and then is sent up to the server. So there's the IP address of this, and I'm going to save this in my notes. By the way, whenever you're doing a capture the flag contest, it's a really good idea to keep notes of the things you find because you often have to use them later. This is the WE8105 desk. We're going to need that again later. All right. So we found the IP address. Now we're going to find their Suricata network intrusion system did detect this ransomware going. So we're going to look at the Suricata alerts. We're going to find server malware. So the alerts are going to contain the word server. So that's a good way to get started. And I think I can actually leave it restricted to this day because I think the ransomware attack was on that day. Let's just put in server. And I get thousands of events, but I want the ones that came from the Suricata. So I go to source, and here you can see, here's the Suricata. There's other events, but these 5 events are the ones I want. These are the 5 alerts that came from the intrusion detection system to warn us about this ransomware event. There were only 5 of them, and now they wanted me to look at the which one alerted the fewer number of times. They want the signature ID value. So here's the alert signature ID, and you can see there are 2 of each of these and 1 of those. So that's a flag, is just which one is here. But for more interesting information, I'd like to look at the signature here. And now you can see onion domain lookup, server check-in, and more server check-in. And if we look at the timeline here, in fact, that was called the alert signature, right? I think another one of those tables would be nice. Let's try that. Pipe table, time, and alert signature. See if I got all that spelled right. Yeah, I didn't get it. Must not have got it spelled right. So I'm going to cut this, run it again, and make sure I can get the name of that field right. Maybe it was Suricata alert signature or something. It was alert dot signature, not alert underscore signature. Okay. So this should be a dot. Okay. There we go. And now I can sort the time here. So here is there. Now I got the time sequence of this just like the one. So at 9:49, 24 and a half seconds, the ransomware checked in. So the ransomware was activated, and the first thing it did was send some kind of network signal to start it. Then 1 second later, it did another check-in, I guess an error response. Then 10 seconds later, it did another check-in error. So it looks like it's trying to check in, but perhaps something like a firewall is blocking its ability to check in. So it wasn't able to tell the master control server that was running, but now it ran for half an hour, encrypting all the files. And when it's done encrypting all the files, it now does an onion domain lookup to harvest the ransom note. That's what's going on. It encrypts your files, then it pops up a note saying, your files are encrypted, you have to send Bitcoin to this address to get them back. So we now know the time frame of it, and we know exactly when it loaded that ransom note. And this is going to be important because of here, we want to examine the fully qualified domain name it went to get the ransom note, and we know what this time is. So one way to focus the time would be to click here and narrow it down, but I'm going to follow a different path here. Well, actually, here we are. Alert signature containing onion domain lookup. There, I found this event. This event is the one where it looked up the domain name. So to get the actual domain name, for some reason, Suricata doesn't log that. So to find it, I need DNS events. The problem is DNS events are dozens or hundreds of them per second all the time. So I need a really narrow time range. So I'm going to go to here, plus or minus 1 second, which Splunk will make easy. If you click on the time, it will now give you a chance to narrow to this range. And it will give you a chance to adjust the range, which somehow I failed. Let me see if I can find it again. 10, 15, 12. Yeah, this is like a millisecond. I want to make it different than that. Restrict the time to within 1 second of those events. I think maybe it's this table that's fouling me up. Let me get this time, 10, 15, 12 is what I want. And I could type it into that time selector, but it's pretty tedious to put. And unfortunately, there's another problem. If the local time here is different than the time zone of the events, then it tends to be off by an hour or two. So I much prefer to do it with the mouse. So here's the 10, 15, 12. If I click it here, this is what I want. I now get a nice box, nearby events, and I can tell it I want to be within 1 second of this time. This is easy to do. And now I've got only those 2 events, but that's because I'm looking at Suricata events. Now I want to look at DNS events. So I'm going to have no restriction here and search those. Maybe I need to put a star in or something to get it to accept. There we go. Okay, now I'm finding the thousands of events that happened in that 2-second period, and I want to find the DNS events, and those are going to be stream DNS. And there's only 16 of them. And I can easily figure out which one of them is suspicious. Look in the query field here, and you'll see Microsoft, Bing, and this domain name, which looks like garbage and contains the word server. This is the malicious domain name that it used to fetch the ransom note from behind Tor. So that's why that's a handy process. All right. And now we want to find what domain was visited by this desktop on this date. So I want to find the Suricata events on that day. So let's go back to here. I'm just going to go here and do 824. I'm just going to clear this out. Instead of being just a 2-second period on that day, I want the whole day. So I think if I just clean those out, nope, it's giving me trouble. All right. Oh, date range. That's why. There we are. This is the one. Date range 0 to 24. Apply. There we are. That's the whole day. All right. And now I want Suricata events. So I go to source type and I find, oh, these are all DNS. Oh, I still have that up here. Let's get rid of that. That's my problem. All right. Okay. Now I can find Suricata events on that day. All right. And there should be 86,000 of them. That looks like it's going to be a lot. Now I want to find the source IP field, and I want it to be the IP address of this, which I mentioned I had to save earlier. So let's go down here for source IP. There it is. And I want it to be that desktop, which was this one ending in 100, 192.168.250.100. So that's just 50,000 events. We're getting there. Now I'm going to look at event type. And I want the HTTP events that Suricata flagged as suspicious. And now I can look at the host names. Now I've got all the websites that endpoint, that laptop visited on that day, and there weren't too many of them. So the host names is here. You can see there are only 10. And again, a bunch of them are obviously harmless, like Microsoft and Windows and Bing. And here's one that looks pretty fishy, solidarityproximity.org. That's the funny looking one, which is the malicious domain. And now we can find the actual code that performed the ransomware attack. So you search for VB script and exe. So let me go back up here. And I think I should still leave it restricted to this day because that was the day the ransomware attack happened. So I just looked for .vbs and .exe. I just read, by the way, that Microsoft in Windows 11 is going to deprecate Visual Basic. As far as I can tell, Visual Basic is used only for malware, VBS scripts. Anyway, I guess Microsoft reached the same conclusion. Anyway, so VBS and EXE, there are only 10 events. And I guess there'd be 16 if I didn't have the date and time restricted. But I want the malicious one, and it's going to be pretty obvious if you look at the body field. A new process has been created. And if you go down here, there's a command line. Okay. And look at this code. Set app data random function. Look at this function name with capital letters and small letters, strangely, and weird nonsense names for variables and methods. This is obviously malware. This is how people write malware to make it, not get caught by scanners and hard to read and everything. This is an obviously malicious command line. So I found the event that has it. And now the entire script. So what is the name of the first function defined in the script? And you can see it here. It was I was looking at the body field. You don't need to look any further than here. Here's the malicious script, and you can see the functions that are defined, and they have random names. So you can figure out which one of them is the first function, and that's one flag. Next one is a field length, which is kind of annoying. I'm not sure it's worth struggling. I had students that get the length of the script by just copying and pasting it into a text editor and seeing how long it is. But for some ungodly reason, the people that wrote this CTF wanted you to get the field length inside Splunk, which is kind of an internal detail. not that important. But anyway, you can get it. You have to use the eval function to get it. But the thing I think is far more interesting is to find the USB key inserted by Bob Smith, which infected him with this ransomware. And this is pretty easy because, as you probably know, Microsoft Windows Registry stores forever every USB device that's ever plugged in, because it has to know if a similar device comes, it already knows what driver to load, and it stores the friendly name of it too. And so friendly name is in the registry will show you the friendly names of all the USB devices. So I want to find registry events. So I'm going to, I think I'm going to go back to all time. I'm not sure if this happened on the same day. It probably did though. But anyway, I'm just going to make a clean search here. And I'm going to, here's all the events. I want to find Windows registry events. So source type, I say there we are, of Windows registry. There's 74,000 of those. And now I want to find friendly name. Now I first have to go to all time though to get them. All right, there they are. All right. And I want friendly name. I think I might find it here, but I think not. I think let's try putting it up here. Probably friendly is all I need. Maybe even just friend. How many registry events contain the word friend? 0. Okay, let me check what my link here tells me. Friendly name is a field. Yep. Used to be on here. Try searching for the word friendly on here. All right. Manufacturer name, driver name. All right. I should be able to find friendly. Let's see. Windows registry. Registry key name. Yeah. Friendly name. And this happens to me a lot. I have procedures I've saved in hints, and then when I try it again, I can't do it. Friendly name. There it is. Wow, I don't know why friend, oh, maybe friend had to be a word. I thought if you put something there, it would just do a grep search, but there is friendly name. Okay. And so there's friendly name. So if I expand this, and then I'll just use Control F to search for it. There's friendly name. Let's see. Object friendly name. Yeah. There. And this is it. The name, this is the name, and this is the value, Miranda Pry. And it's again from the movie. There was a character named Miranda that did something bad. So that's the actual name of the USB key that was inserted. And
so how'd you get that friend or that output that made it easy to see them? What's that?
I had to put in exactly that thing, friendly name.
So I got friendly name in there, but where it makes it all pretty so you could read it all?
Oh, I hit a little thing here to expand it.
Okay.
There's also different views here. There's list view, raw, and table. And for this kind of thing, raw view might be better. But yeah, there's different ways to look at it. Yeah. But this little arrow here. Anyway, that's useful stuff. And I think that might be enough. I don't think it's worth going through every detail after this. There's things where you find how many PDFs were encrypted, how many text files were encrypted, and so on. But I think you've seen the high points. So I think I'm going to stop this video.